Sorry, we're getting a little bit of a late start. Let's talk about the syllabus first. This is linear algebra, Math 205. My name's Caitlin. Before we talk about the syllabus, I know most of you, but not all of you, and I don't know if you all know each other. So let's just do a quick name and major as we go around the room. Okay, so looking at the syllabus, there's a little typo on most of the syllabi. For Mondays, the office hour is actually 4:30 to 5:30, not 1 to 2. And Wednesdays, I do plan on being on campus for at least a few hours. So if you let me know that you're coming, I will make sure that I'll be here. Okay. At whatever time you might need to see me. And email me anytime. Let me know if you want to meet me at another time other than my office hour or with a question, whatever. Okay, so I'll let you read the description on your own. It's hard to sort of describe what linear algebra is without knowing some background information, but we're going to start by solving systems of linear equations. And you're all probably like, I know how to do that, right? So we're going to start with that, and we're going to learn some new techniques for doing that. And then that's going to lead us into some much more abstract thinking in algebra. All right, so what you can expect in class. If you have questions from previous classes or for homework, try to come to my office hours and ask me outside of class or the math studio. I have studio time 9:15 to 10 before our class on Tuesday and Thursday. And then class will be start with a 2-minute quiz based on your reading of the textbook. And you guys are going to write the questions for the quiz. And they can be really easy questions, right? So you're going to do the assigned reading. You write one easy answer question, like a fill in the blank or a true false, something easy based on the reading. And then I'll pick 3 questions, put them on the board, and that'll be your 2-minute quiz at the start of class. And there's a more detailed explanation of that a little further on in the syllabus. But each class will begin with a 2-minute quiz on the assigned reading. We'll review the quiz, and then the rest of class will consist of a mix of short lectures and group activities. So some classes will have more lecture, and some classes will have more activities. It's going to kind of vary. And then you have all of your homework assignments and reading assignments listed at the back of your syllabus for the whole semester. There's a list of resources for extra help here. And all right, let's get to the meat of it, your grade, right? So your grade is going to be based on attendance, your reading score, homework, quizzes, exams, and the final exam. So each day that you come to class, you get a perfect score, so long as you show up on time, stay the whole time, work well with your classmates. I take attendance using these folders here. So if you've had a class with me or many of the other math professors in the department, right, just put your name at the top here, and each day just put a check mark next to indicate that you were here. So self-reported attendance. And we're also going to use those folders to record your 2-minute quiz grades. Okay, so you're going to, next to each date, there's going to be a check mark and a score that you're going to self-record. And I'll talk about the quizzes a little more in a minute. Okay, so your reading score is based on your 2-minute quiz score and writing a question. Homework is listed in the syllabus, and I'm just going to look at it. I'm just going to walk around, take a quick peek, make sure it's well attempted, and you'll get credit for your homework. I think, what did I say? Up to a week late, I think I said I'd take it. Something like that. Quizzes, there's 7 quizzes throughout the semester. They're all listed in the schedule at the back of the syllabus, so you'll know when they're coming. You can bring a 3x5 note card with you to each quiz, and Technology allowed for quizzes and tests may vary. I'll let you know as the quiz or test is coming up what you're allowed to use. 2 exams and the final exam. And then you have 2 options, test light and test heavy. You don't have to pick one. I'm just going to calculate your grade both ways and give you the better of the 2 grades. All right, so for makeups, if you miss something, you can't make up a quiz and you can't make up attendance. All right, so if you are absent, you just don't get your attendance points, but you can miss up to 3 classes with no penalty. Quizzes, if you miss a quiz, I'll use the exam that covers the same material, right? That next coming up exam to replace the quiz score. So it's not like you'll get a 0 even though you can't make it up. All right, so reading assignments. If you miss a 2-minute reading quiz, we'll come back to that and see what to do if you miss a 2-minute reading quiz. Homework accepted up to a week late, no penalty. More than a week late, half credit. And generally no makeup tests. If you just don't show up for a test, you'll get a 0. But if you have some kind of emergency or circumstance, like just contact me as soon as you can. Let me know what's going on, and we can figure something out. All right, so for reading assignments, for each reading assignment that you have, you'll be required to read the section or sections identified on the assignment sheet. You're going to be required to create 1 simple answer question on the material in that section. You could use a fill in the blank, a true false, a short answer. These are the potential 2-minute quiz questions. So you're writing the questions for the quiz. Put them on a 3x5 card. Make sure you label it clearly with your name, the section number, and put the answer on the back of the card. So having written 1 question earns you 1 of 4 points on your reading quiz. The other 3 points you earn by getting the 3 questions I put on the board correct. So your 2-minute quiz. Okay, so I'll choose 3 of the questions. I may or may not use your questions. I might make up one of my own on the fly, but I'll mostly use your questions. And you can get 3. There'll be 3 questions, so each one gets you a point. Each one you get right gets you a point out of 4. And then optional, you can take 1 or more pages of notes on the reading, and should touch on everything. Good notes, and this can replace 1 incorrect question on a 2-minute quiz. So the maximum, there are 5 possible points in there: your question, your 3 questions on the quiz, and notes. The maximum you can get is 4, but if you take notes, then you could get a question wrong. Still get a 4. If you miss a reading quiz, you can do nothing and get a 0 for that day's reading score. I will drop 3 lowest reading scores, so you can get 3 0, miss 3 things, and it's no big deal. Or you can show me your notes and your question, and that will earn you 2 of the 4 points. All right, so here's our schedule for the semester. Over here on the left is just a list of lesson numbers and topics, section number, lesson number, section number, topic. And then over here on the right is our actual schedule with dates and stuff. So for each date, there's the lesson covered, the homework due the next class, and the reading for the next class. And then quizzes and tests are marked in here with asterisks. Questions? Oh yeah, the final exams are only is 15% in both cases. Yeah. Yep. Yeah, yeah. I just didn't want the final exam to be that heavy. That's all. In general, if you do really well on your final exam and that is like a significant improvement for you, yeah, I'll rework things. You know, I'll keep that in mind when doing your final grade calculation. What are the format for the quizzes? The quizzes are 2 parts. Okay. First part group quiz, second part individual quiz. Okay. Okay, so it'll be a good chunk of time we'll spend on quizzes. and the group part and the individual part will look similar style questions, but they're not going to be like the same questions, different numbers. Yeah. But they'll be very similar. So the group part is meant to help you review, get everything straight in your mind, and then you take the individual part after that.
Class period?
No, I don't think that I allotted a whole hour and 40 minutes for it. It's usually like here we're going to do 7F, which means finish lesson 7, and 8. And so lesson 7 was applications of linear systems. So we're going to finish up a lesson and then do the quiz. Right, so we'll probably do like 20, 30 minutes and then the rest of the time for the quiz. You do get a whole class period for tests, unless we want to spend 10 or 15 minutes reviewing, because there's going to be plenty of time to take the tests. Any other questions? Okay, good. So if you've had me or Linda or Ian or pretty much anybody in the department, you know that we work out of these packets. So this is your packet that goes up through the first test. It's for you to take notes in, study from. There's a study guide at the back of it for test 1. So let's get started here. All right, so first lesson, we're going to review and extend our knowledge of sets and set notation, and we're going to start learning about how to write proofs. Okay, so a set is just a well-defined collection of things, elements, or numbers. Well-defined means there's no ambiguity about whether or not something belongs in the set. If I define it, you can easily say, yeah, that's in the set, that's not in the set, that's in the set, that's not in the set. A set can be finite or infinite, have a finite number of things or an infinite number of things in it. Some common sets of numbers are the integers, the rational numbers, the real numbers, and the complex numbers, and they all have special symbols. So Z is standard notation for all mathematicians. That means the set of all integers. And I tried to make it fancy. Typically, you'll see it Z with like a double line when it means the integers. Q, and all of them have a double line. It'll be Q with an extra line, R with an extra line, and C with an extra line. I couldn't get my fonts to do it. All right, so there are several ways to describe the elements of a set. 3 common ways are to just describe in words the things that are in the set, list all the elements in the set within curly brackets, and that's called the roster method, or set builder notation, which you may have less familiarity with, and we'll do some practice with it. It generally looks like the set of all x's such that x fulfills some conditions. So this symbol that looks like an E, like a weird looking E, it means is an element of. So for example, you could write 8 is an element of Z. 8 is an element of the integers. All right, so let's think about the rational numbers, set of all rational numbers, and we're going to describe it 3 different ways. In words, who can tell me what a rational number is? Yeah, it's a fraction. The top and the bottom of the fraction have to be, can you have like pi on the top of a rational number? Yeah, it's a fraction, any number that can be written as a fraction where the top and the bottom are integers. I'm going to change the word fraction to ratio because it's the root of the word rational. Written as a ratio of 2 integers. The roster method, if I wanted to list every single rational number, how many are there? Infinite, so I'm going to have to use some dots, you know, some ellipses to mean keep going like that. So to list them, I'm going to start with all the fractions that have 1 as a numerator, right? So I could have 1 over 1, 1 over 2, 1 over 3, etc., right? All the fractions that have 1 in the numerator. So what kind of fractions should I list next? All the fractions with 2 in the numerator. 2 over 1, 2 over 2, 2 over 3. What do you notice so far? Oh, okay. Yeah, yeah, I'm actually not going to try to generalize.
Oh.
Yeah. But I've listed an element twice in here. 1. Yeah, I have 1 over 1 and 2 over 2. Whatever. Right? If I list a few things multiple times, we typically don't do that, but there's no way to write out all the rational numbers in roster form without accidentally rewriting some stuff. So again, 3 over 1, 3 over 2, 3 over 3. I've listed 1 again, but oh well. Dot, 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 dot. So if you kept going like that, you would eventually list all the rational numbers. Well, I mean, you can't list all of them, but set builder notation is a much more efficient way than either words or the roster method to describe all the rational numbers. So I would write something like this. I would say the set of all fractions, you said, right? Or ratios. So I'm going to write a fraction with generic letters, A over B, such that A and B have to be integers. So I would write A, comma B, A and B are elements of what? Z. Elements of the integers. Yeah. Oh, yeah, it does. Good point. Put a little plus or minus in front of all these. Okay, so a set with nothing in it is called the empty set, also called the null set. You can denote it by putting 2 brackets with nothing inside or a circle with a line through it. Okay, one way to describe 2-dimensional space is the coordinate plane. You've dealt with that a lot, you know, the XY plane. It's often denoted R2, R with a exponent of 2. And every point is given a set of coordinates x comma y. And in this course, we're often going to express the coordinates of a point in a vector instead of as a x comma y, a vertical xy. So if I wanted to describe all of R2 using set builder notation and vectors, I would write it as the set of all vectors xy such that, vertical line means such that. What has to be true of x and y? What kind of numbers are they? Reals. If you want to describe the whole plane, got to include all the numbers. So x and y are elements of R. Yes. Well, only because I asked you to use vertical vector notation. Yeah. 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 If this x comma y means the same thing. You could write set of all points x comma y such that x and y are elements of R. That would also be correct, except for the fact that I asked you to use vertical notation. Yeah. All right, so on the next page, I have a little bit of activities for you to do with sets, but I'm going to have you jump a couple more pages to the writing proofs page. It's page 4. We'll do a quick quick lesson on writing proofs, and then I'll have you do some activities in your groups. So proof is an argument designed to convince someone that a statement is true. It's similar to writing a piece of music. The process is both creative and logical. There are rules and customs that you follow, but there's no like procedure, like do this and then this and then this, that could get you a piece of, that would write you a piece of music or a mathematical proof. It's a skill, you develop it over time, practice, and patience. So there are lots of types of proofs. The majority of the proofs that you'll see as a student of math or engineering or computer science are one of these three types: direct proof, proof by contradiction, and proof by induction. Today we're just going to talk about direct proofs. So most theorems can be written in the form if triangle then square, if something then something else. Triangle and square are they themselves statements that are either true or false. The statement triangle is called the hypothesis of the theorem. Whatever goes with the if is the hypothesis, and square, the thing that comes with the then, is the conclusion. In a direct proof, you just assume that triangle is true. You say, okay, assume triangle is true, argue, 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 therefore square must be true. All right, so our goal, our first example, is going to be to prove that the sum of two even integers is even. So you can do several examples in your head to convince yourself that it's probably true. 2 plus 6 is 8, yeah, even plus even, even. 12 plus 4 is 16, yep, that one works. So you do several, but you can't test every possible example, right? You can't, because there's an infinite number of even numbers. So you can't just keep testing and testing and testing. You have to write a proof that shows that it's true for every single even number. All right, so it's customary to sort of follow your nose, work on trying to prove it, and then once you've got it, to rewrite your proof in a nice clean format where you leave out sort of any dead ends, things you tried and didn't work. All right, so here are three pieces of information we're going to use to write our proof that the sum of two even numbers is even. First, anytime you add two integers, you get an integer. And anytime you multiply two integers, you get another integer. So I'm going to let you just use that fact. It's a theorem that we could prove separately, but we're just going to use it. An integer, the definition of an even number or an even integer is that if a number is even, that means it can be written as 2 times an integer. Everybody see that? So 8 is even because it can be written as 2 times 4. 12 is even because it can be written as 2 times 6. Right? 13 is not even because if I wanted to write it as 2 times something, I would have to use 6.5, which is not an integer. And anytime you, oh, this is the theorem we're going to prove. Right? When you add two integers, the result is even. So this is what we want to prove here. All right, so first, rewrite the statement as an if-then statement. The sum of two integers is even. How could I rewrite that as an if something, then something else?
If two integers are added together, then the result is even.
If two even integers, yeah. Let's rewrite that. If two even integers are added, the result is even. I should say then the result is even. Okay. So in a direct proof, you assume the statement that goes with the if. So we assume you have two integers. So let's give them names. We're dealing with two integers. Let's call them n and m. Assume n and m are even integers. So that's where we start. And then it's often helpful before you start writing your argue, argue, argue part to think about where you're trying to go, right? So NTS is short for need to show. What do I need to show here? in order to have proved it? Is even. Yeah. Oh, you have an idea? Go ahead.
Divide n and m by 2, and then add the 1/2 of n to 1/2 of m both times. You have the same number, which is the same number added together by that.
I think you're on the right track because you know n and m are even. That means they're 2 times something, which means they can be divided by 2.
Add that number, what you get when you divide it by 2. You end up with 2 halves.
Yes.
And
Yes.
you get the same number.
Yeah. This would get you there, but I think like I could go here to here and you're kind of going like that.
Oh.
Okay. I'm just going to do it a little bit straighter line, but it's the same logic. All right. So if n and m are both even, using the definition of even, I could say, note that by definition, n is 2 times some integer. And m is 2 times some other integer. They're not necessarily the same integer because n and m aren't necessarily the same number, right? Okay. Where j and k are integers. Okay. So I'm trying to prove something about n plus m. So let's add n and m together using what they're equal to now. So I'm going to say thus n plus m equals 2k plus 2j. Can I, yeah, factor out the 2? Factor out the 2 and I'm left with k plus j. K is an integer and j is an integer. K plus j is also an integer, right? Adding 2 integers gives you another integer. That was theorem 1, right? So 2 times an integer, that's the definition of an even number, right? So let's just, I'm going to write this a little bit informally. This equals 2 times an integer which is the definition of even. Thus, by definition of even, n plus m is even. And when you proved it, you put a little box with a check mark. So yeah, proofs are generally written in sentences and paragraphs. Even when you're doing a lot of symbol manipulation and there are equations within it, there are sentences. Yes. Yes. That's a great question. So we used a theorem in here, right? Theorem 1. How far back does that go? You can build up all of number theory, which is a little piece of this, using definitions. You have to start with some things that are defined. Definitions can't be proven. They're things that we just said, okay, let's we just assign definitions. Like a square, you know, we just said, is that kind of shape that has 4 equal sides and a right angle, right? Yeah. Mm-hmm. Yeah, this is called the axiomatic method, where you build up all of mathematics from a base of definitions and axioms. So there are certain things, definitions that we just invented, and then there are certain axioms that are unprovable statements that we have to assume to be able to go anywhere. Yes. The definition of an integer, can somebody help us out? What's an integer? It's just the positive and negative counting numbers and 0.
That's a definition.
That's a definition. Yes. We just decided there are counting numbers. We can make them positive and negative, and we'll call them the integers. Yep, it's a set, yeah. All right, so the next 3 exercises are for you to work on your own. Okay. So for homework, so for some activities / homework, whatever you don't finish in the time I give you right now, you're going to work on, starting on page 2, 1 through 4, and then 5, 6, and 7. There's 3 worksheets. Sedek and Gallo, the even problems. Finish the writing proofs handout. There's the 3 proofs you got to write. And then there's a background homework sheet. And they're all in the pages that follow. So let's see, it's 11 o'clock and we have class until noon. I'm going to give you a good 30 minutes to work on this. Whatever you don't finish will be homework, and then we have another lesson to do in the last 30 minutes.